Okay, well, good morning or good afternoon or good evening or whenever you're watching this. I'm recording this in January of 2020 because I have an example to show today of how commissioning can fail. And so I want to walk through that. By means of introduction, my engineering team, has been looking at commissioning quality for about the last 2 to 3 years. So every time we get a commissioning report, we fill out a quality checklist. And within that checklist, we have four very key heavy questions that we call litmus tests. So first, is there an issues log? Sometimes we get reports that don't include a list of issues, or they say, well, there were no issues. That's sometimes hard to believe. So first thing we look for is, do you have an issues log? And then the second question is, did all the issues on your issues log get resolved? Is there documentation that says every issue that came up got resolved? We want to make sure everything that's found not to be working winds up working before we close out the project. And then the third one is, did we do a demonstration period? So for HVAC systems, this is usually a trending period to demonstrate that the systems are working according to the design intent. And then finally, did those systems in fact work according to the design intent during that trending period? So those are the four questions that we asked. What I'm going to show you today is primarily an example of question 3 and question 4 about the training period and working to the design intent. Before I do that, I'll show you what we mean by working to the design intent. We've actually developed in the last few years these acceptance criteria, and we have the engineers put them on the plans or on the specifications. So we try to be very, very clear, numerically clear about what we expect to see during the training period. We want to see the rooms in control. We want to see economizers work. We want to see fans and chillers and boilers and pumps ramp up and ramp down as the weather ramps up and ramps down. And so that's what I'm going to show in these next few slides. It's an example from a project that did their training period and has the results to show. First things first, we always want to see temperature in control. So nowadays we've simplified this to just ask for plus or minus 3 degrees of set point for 90% of observations. But for this test, we use this definition of a comfort event, right? One comfort event is when the zone is more than 3 degrees out of set point for more than about 2.5 hours. And as you can see, over a 6-day training period, we do have a bunch of zones here that really aren't in very good control, right? The worst is zone 8, which had these 14.5 comfort events. That's to say that it was out of range for significantly more than 3 hours a day, every day during the training period. We also have a good number of zones that have more than 6 comfort events, which is to say that they were out of range for at least 2.5 hours on an average of once a day, right? So this is not good. We don't have good comfort control in this building, and we would have to say it failed this condition of acceptance. The second one is that we have some critical rooms here with pressure controls. Those pressure controls are not cheap, right? So we installed the pressure controls, and they're supposed to be between 0.01 and 0.03 pretty much all the time. And we have an allowance for door openings, so you should be able to see the doors open. And we asked for 5 days of training on this. And you can kind of see the trend of pressure here. It fails the criteria. What's kind of weird is that it looks like it complies or even over complies during the unoccupied periods, but most of the days, during the day, this looks like it's not meeting our acceptance criteria at all. We also want to look at the zones and make sure that they're doing variable volume according to a predictable sequence. So the picture that you see off on the left there with those two nice, neat looking triangles is what we expect a VAV system data to look like. And then the rest of the pictures are the ones that come out of the real project. So when I look at these, the first thing I look at is the width of the data. So from right to left, that tells you how tight your control is, right? If you were within 2 degrees or 3 degrees, then everything would be crunched together in a nice 2-degree band. So obviously in these zones, we have some very wide sways in temperature. Next thing I look at is the orange. That's the position of the heating valve. And first things first, the heating valve should be closed when the room is warm. So on the right side of the chart, the heating valve should be closed. And in this data, it's not. We are seeing heating valves that are fully open when rooms are above set point and should be calling for cooling. Kind of the same thing on the blue side. You should never really see blue dots up at the far left side of the graph, right? That represents a zone that's cold, and it's using 100% of the air in the zone, which really shouldn't happen. So here we're seeing those blue dots kind of all over the place. And this is every zone. I didn't show every zone here, but these pictures look pretty similar across all the zones. The next one here is economizers. Economizers are actually a pretty old strategy. They've been around in HVAC as long as I've been around in HVAC, and we rely on them a lot, particularly in the mild climates, right? So if you look at the engineer's energy models, the economizer is supposed to be open every hour that it's supposed to be open, and then closed every hour that it's supposed to be closed. And so our acceptance criteria is that we would trend this for 5 days, and not more than 10% of the points should deviate from the intended position of the economizer. And then what you see down at the bottom is the real data. And a couple things. Notice the big block of points down on the x-axis. That's the 0 point. And in particular, if you look between 60 and 70 degrees, those are all the hours when the economizer is supposed to be working, but it's not opening. It's closed when it should be open. So we're not getting the energy savings that we want to be getting. The commissioning team did not quantify that, but I'm guessing that they didn't meet the 90% threshold here. This is also only 1 day's worth of data, so that's kind of a problem. We need a longer training period to really demonstrate that these things are working correctly. And honestly, those 0 points are a little bit concerning to me. We actually never really want to see an outside air damper fully closed unless the unit is off. If the unit's off, then we should not really be showing those points on this chart, right? So seeing a bunch of points down at 0, to me, that indicates we have 0 outside air in that unit, and that's not correct. So this is a really big one. When we put in a VAV air handling system, we expect it to ramp up and ramp down with the temperature. The top graph that you see on this slide here comes from the engineer's energy model. So if you run the calculations, you run the prediction, that's what the VAV is supposed to look like relative to outside air temperature. That's the predicted behavior. The bottom chart is the actual data. And just in case you can't read the numbers, during the training period, the outside air was between 30 degrees and 75 degrees. You can kind of see this slight dip in the data between 40 and 50 degrees, but other than that, it really doesn't bear any real resemblance to the chart above. And it's pretty broad, right? Those fans are ramping up and down between 25 and 40%. They track speed here rather than fan power, but that's okay. This data isn't terribly surprising at this point in the presentation because we've already seen the zone data. And that's sort of a logical following, right? If the zones are not in control and the zones are not working the way that they should, then it sort of logically follows that the fans that are serving those zones are not going to be in control and not going to act really the way that it should. That holds true for the next chart that I'm about to show you. So finally, this is the heating system. And again, that chart in the upper left is from the engineer's energy model. So that's what the heating system is supposed to look like. When it's less than 60 degrees, you should see it ramp up. And then the chart in the middle is the real data. And people laugh at me when I say this in public. They say I'm crazy. But this kind of shows you in data form that the boiler system here is pretty much running independently of the outside air temperature. There are some dips. When we get to 75 degrees, this heating system drops off by about 30%. But other than that, it just sort of runs. and it really runs almost independently of the outside air temperature. This commissioning team didn't even try to plot the boiler capacity versus the outside air temperature because there's obviously no relationship. The chart up in the top right is the pump speed. And so again, we were varying between 30 degrees and 75 degrees outside. And those are the heating hot water pumps. They're just running. They don't care if it's 30 degrees or 60 degrees. There's actually 2 pumps in this system, and they're both running at 70 to 80%, like all the time. So if the design intent was to sequence those pumps, well, that's not really happening, right? So I hope you noticed in this short presentation that I did not include the name of the project or the engineer or the controls vendor or the commissioning team. I edited those out, and I edited them out on purpose. Because I will say, on one hand, this is actually a great report. Our commissioning agent performed the testing, performed the trending, documented the results, and very clearly presented those results back to us. On the other hand, they very clearly presented results of a building that's not working according to the design intent. And commissioning is supposed to be a quality assurance process. We had them on board during design. They reviewed the engineer's plan. They reviewed the sequences. They reviewed the control submittals. They reviewed the installation. The report that I pulled this from is a 2,000-page report. So there is no shortage of checklists and documentation, right? This is a full-blown commissioning process producing a 2,000-page report. But at the end of all of that, we got zones that are out of control. We got VAV zones that don't appear to be working according to a VAV sequence. The VAV air handlers don't appear to be working to a VAV sequence. The economizers don't appear to be working. The heating hot water pumps certainly don't care if it's 65 or 35 degrees outside. So this building is not going to match the design energy model. It's not even going to come close. It's not doing anything that the design energy model had intended. And this is the emphasis of our commissioning program. We want our commissioning teams to get the building systems to work. And I hate to sound like a total skeptic or a total naysayer, but if you designed it or if you intended it, but you didn't measure it, then in my book, it didn't happen. We've just seen this way too often. We can only know that those building systems work when we have the data to prove that the building systems work according to their design intent.